The James Webb Telescope continues to work for the benefit of science. Unfortunately, the hype around the project has weakened, so new photos are of little interest to anyone. The telescope shared incredible photographs of the embryo of the solar system, dark matter, and one of the most unusual objects in the universe, the Quasar. We will analyze the most interesting photos in the next couple of minutes after you subscribe to the channel. Let's start with the star system fetus. James Webb photographed it in early October. The object in the photo is called Orion 294606 and is located 1,400 light-years from Earth. As you can easily guess, the star is located in the Orion Nebula, the brightest and closest star-forming site in the Milky Way. Roughly speaking, this is a big maternity home for stars. Well, the photo shows one of these newborn luminaries. The star is very young. It's only 1 million years old. By cosmic standards, this is just a hatched chick, emphasized by a black disk that blocks part of the light. This disk is the dust and gas left over from the molecular cloud that formed the star. By now, every student knows how this process takes place. A cloud of hot gas is compressed so tightly that a thermonuclear reaction begins, synthesizing helium from hydrogen. James Webb also took a photo of a similar protostar, and we analyzed it in one of the previous videos. What matters for us is that not all of the cloud material goes into the star. Part of it remains in its orbit and begins to shrink under the gravity of the young star. This cloud is called a protoplanetary disk, and scientists have photographed quite a few of them. But what is truly fascinating is that this process was predicted and described even before scientists had powerful telescopes. What we see now in James Webb's photo is not a discovery, but a confirmation of theories that were developed at a time when computers did not even exist. Impressive, isn't it? But how could scientists even come up with such a thing? To answer, just look at the model of our solar system. As you know, there's no concept of direction and cardinal points in space. It's voluminous, endless, and stretches in all directions. Gravity also works in the same way. No matter which side of the Earth is approached, its influence will be the same. However, for some reason, every single planet in the solar system is strictly on the same line. The main rebel in this scheme is Mercury, but it too deviates from the line by only 6.3%. So our solar system, even though space is 3D space, for some reason, it's 2D. It gets even weirder if we move a light year away, turn around, and look at the sun. It will be seen that the solar system is still a three-dimensional ball. The Oort cloud does not extend in a line, and objects outside Neptune rotate in all directions, forming a sphere. And yet the 8 planets are on the same line for some reason. The rest was a matter of technology for the scientists. Simulations were performed, which showed that in 3D space, severe gravity forms around a young star, quite a 2D cloud. And in this cloud, quite massive objects in the same scheme devour matter, get a spherical shape, and turn into planets. With the invention of powerful telescopes, the theory has been brilliantly confirmed. We photographed dozens of protoplanetary disks, and they were all flat. The planet's location in line with the sun is not a thing of our solar system, but a law, which James Webb's photo confirms. The black ring around the star is a protoplanetary disk. Its diameter is 300 astronomical units. That's 300 distances from the Earth to the sun. At first glance, this system is larger than ours. After all, our last planet, Neptune, is located at a distance of only 30 astronomical units. But in reality, things are a little more complicated. Far, far out, the most distant trans-Neptunian object we found is at 132 astronomical units, and it's far from certain that it's the last one. The truth is that we don't know the solar system's boundaries. There is an estimate of 180 astronomical units. There are 80, and there are generally 500. It's not just about physics. The point is in definitions, because we don't know what to consider as boundaries at all. In general, this is another story, and our object, Orion 294606, is in the process of planet formation, which scientists will continue to observe. Well, we'll move on to the photo of the Quasar. James Webb shared a unique shot of one of the brightest objects in the universe, 11.5 billion years old. A quasar is a complex object that some people confuse with black holes, and some, on the contrary, consider it to be the opposite of a black hole. In reality, everything is more complicated. A quasar is really a black hole, but not only one. It is instead a collection of everything close to an incredibly active black hole. Usually, we're talking about the early stages of its life, when the galaxy in which the black hole is located is still very young. Later, the black hole will eat everything it can, calm down, and the quasar will cease to exist. Thus, a quasar is a certain period in a supermassive black hole's life inside a galaxy. Under the influence of an insane mass, the quasar is gaining substance, and the forces of friction and gravity heat it to an insane temperature and accelerate it to insane speeds. The bonfire turns out to be incredibly bright. Therefore, quasars are almost the brightest objects in the universe. And for astronomers, they're kind of lighthouses. Everyone knows where they are, and the sky is easy to navigate if you look at the nearest quasar. This is the core of the galaxy UGG 8058, 600 million light-years from Earth. In total, about 200 quasars are known to humanity. They are of great interest to scientists. After all, thanks to quasars, you can learn more about the processes of the birth of galaxies. The quasar photographed by James Webb is 11.5 billion years old, and therefore, it allows you to learn not just about the birth of galaxies, but about the birth of the very first clusters of galaxies in the universe. This is the main news related to the photograph of Webb. The analysis shows that not one, but 3 galaxies are located around the quasar. That is, we can see the oldest cluster of galaxies, which at that moment in the life of the universe were rare. Furthermore, 3 galaxies rotate around each other at an insane speed, which according to the researchers can't be simply explained. No matter how powerful and heavy a quasar is, this is not enough to disperse as many as 3 galaxies to subliminal speeds. Moreover, according to Dominika Wilizalek, one of the study's leaders, even dark matter is not enough to justify the speeds captured by James Webb. Based on this, scientists conclude that the frame in front of us is not just a quasar and 3 galaxies. Somewhere out there, whole clusters of dark matter also collided, which helped the galaxies achieve the desired momentum. In general, we see an insanely epic spectacle, even by space standards, but we can't explain it yet. Who knows? Maybe James Webb's data will bring scientists closer to the secret of dark matter and its future detection. But we will discuss it later. In the meantime, let's move on to the third photo. It shows the legendary Pillars of Creation, which look like Thanos' Infinity Gauntlet from this angle. The object was discovered a long time ago, in 1995, using the Hubble telescope. The pillars are located 7,000 light-years from Earth in the Eagle Nebula. The object got its name because of the processes directly opposite each other, which occur in the photo. On the one hand, the Pillars of Creation are accumulations of gas and dust, where stars are born according to the process we've already discussed. But on the other hand, when stars are born, they devour this gas. Once formed, they blow into space with their solar wind, blowing the remaining gas far away. There is a situation in which the pillars give birth to stars, but they're destroyed during this process. Once, it was a large monolithic cloud, but the stars were born, and now, the cloud seems to have been eaten by erosion, giving birth to a beautiful landscape. By cosmic standards, the pillars are not that big. From base to peaks, from 4 to 6 light-years. That's the same distance from us to the nearest star Alpha Centauri. According to some scientists, the pillars no longer exist. In pictures taken by the Spitzer Space Telescope, astronomers have discovered a supernova that has exploded nearby. The emergence of the cloud suggests that the explosion occurred 6,000 years ago. And since from us to the object is 7,000 light-years, in the near future, scientists will observe the slow process of destruction of the space attraction. This, of course, is far from being true. But for understanding the scale of space, the information is very entertaining. And finally, let's go to the distant past of the universe. So far back, if you imagine a time elapsed from the Big Bang to the present day to be 100%, this JD galaxy in the picture existed when only 3% of the time elapsed from the Big Bang. It's no more than 400 million years old from the beginning of time. Before, in Hubble's photos, scientists could only see a red dot. When James Webb got involved, scientists saw details of the oldest galaxy and discovered that there are 2 galaxies. That is, we're faced with two galaxies colliding almost immediately after the Big Bang. Gravitational lensing helped to consider it again, reflecting the JD galaxy thrice. If, looking at this photo, you want to revise Interstellar, we understand perfectly. Christopher Nolan almost perfectly reproduced the appearance of the wormhole, in which James Webb's photograph is a gravitational lens that allows us to see the light from two galaxies that crashed into each other more than 13 billion years ago. Let's hope no one was hurt in the collision. Well, that's all for now. If you liked it, don't forget to like and comment on it. See you soon, friends.